Okay, now we're getting into the belly of the beast here. So for example 2, we are going to rewrite in terms of sine and cosine. Notice every single time, even though I'm just saying sine and cosine, you have to have this angle measurement that goes with there. It's like having a square root function without anything underneath it. It doesn't make sense. Sine, cosine, any trig function, you have to have that angle measurement input, something written there. If you simply put sin on your paper, that doesn't make sense. If you simply put cos on your paper or any other trig function, that doesn't make sense. You have to put that angle measurement that goes with it. That is all part of it. It all goes together. Okay, so I just wanted to, hop on the old high horse for a second there. All right, I want to write tangent theta plus cotangent of theta in terms of sine and cosine, and then simplify. It looks like all one word. That's 2 words. In terms. The sine and cosine and simplify. So if I have this is an expression, right? There's no equal sign. I'm not solving. We don't get that till the end of this chapter. So this is simply an expression that I'm looking for. So I'm going to rewrite tangent to be sine over cosine because we know our quotient identities. You have to have those memorized. If you're just looking back and forth the whole time, that's not going to be helpful. It needs to be memorized so you can recall it quickly. Recognize and recall, recognize and recall. Plus cosine over sine. Now, anytime I add, you have to get a common denominator. So here, my common denominator, you got to represent, right? I got to represent everything that's there. So my common denominator is going to be sine theta cosine theta. That means over here on the left, I'm going to multiply by sine over sine. On the right, I'm going to multiply by cosine over cosine, which means I have sine squared over cosine squared. And some of you, are you starting to pick up on this a little bit? Here's the point. This is the thinking part that I want you to see. As I'm putting this together, I want you to start thinking about different identities. So common denominator, add the numerator, sine squared theta plus cosine squared theta over sine cosine. Now, think back to all of your identities, and here's the key. If you just keep that toolbox, those identities, this is the whole purpose of this, to be thinking of those identities. I know that sine squared theta plus cosine squared theta is equal to 1. So if these are equivalent, you can replace sine squared plus cosine squared with simply a 1. And that is your final answer. Did I freak you out, or are you doing okay? All right, so here's the deal with this. You need to be able to think through your identities and be able to move them around a little bit. But more importantly, this is practice with those identities, so hopefully you can memorize those more efficiently, right? Because you're using them. And this is all about manipulation. This is just algebraic manipulation with trig. Using some trig identities, getting a common denominator, recognizing those identities. That's our purpose with this chapter. That's our goal. All right. Now, with that being said, my math lab, I don't like how they do this. How they do verifying an identity. I said proof, it's verify. Verify the identities. Because they walk you through it too much. The answer to these problems is the process. So the whole answer to these problems is the process. You already know the answer because I'm going to give you something that's equal. So I don't like how they do this. They don't let you think through that process. You may choose to go a different route, and that's okay. So because of that, the problems for this homework, the only thing in your homework is you were going to have odd even, like what we just talked about, and change to sine cosine, like what we just did on that last problem. So that's it. Now, this chapter does a whole lot more than that. I have uploaded into Canvas some practice, 10 problems that you need to do. I'm also uploading solutions on how to do those. This concept in trig, so there's two, in my opinion, and you know I got one. In my opinion, the two primary things that you have got to get out of trig. Number one, the unit circle and how to use it. That's huge. Capital H, capital U, capital G, capital E. Huge, huge. The unit circle is huge. Okay? Let's write some of this stuff down. Main trig concepts. Unit circle, which we covered in chapter 9. And here's the second one. That's a biggie. Verifying trig identities. And not because it's a skill in terms of how you're going to use trig and how, application, take that back. It's not because it is a skill, but it's not an application base that you're going to be doing this, all right? You're not going to walk around verifying trig identities. You're never, ever, ever going to have to do this again. The skill, however, that you're going to gain from this is the problem solving, the manipulation of trig and how it works, and being able to make connections between those identities, all right? So you're getting problem solving skills, which is such a big deal, you guys. Problem solving skills, manipulation of trig identities. That's a big one. Getting comfortable with those identities. How are these equal? How can I work with this and manipulate it? Because that's what trig's about. That memorization and making sure that you get that set up. That is what it is. This is more skill building than application building. All right. The unit circle, the unit circle is major application. This that we're doing now is skill building. All right. Okay, so let's do one. Here's example 3. Verify the identity. Okay, I have cotangent x plus 1 equals cosecant x cosine x plus sine x. Now, when I go through and I look at these problems, a lot of times I think it's easier to go for the crazy one. So the crazier the problem, the easier I feel like it is to work with. All right, so the side. Now here's the deal. The answer is there. I know for a fact this is an equal sign. This left side equals the right side. Here is my goal when you verify an identity. So how do I want to say this? Start with the craziest looking side. Okay. Oh, here's another biggie. You cannot cross the equal sign. You're not solving anything. You cannot add or subtract, multiply or divide anything across those equal signs. You have to keep this as a brick wall. You cannot cross that. All right? I'm going to shorten this up a little bit here. All right? That's a big deal. So if I'm looking here, let's go back to blue and I'm going to scoot it over. cotangent x plus 1 equals cosecant x cosine plus sine. Getting ready to write a theta because I'm so used to putting it. All right, so I'm going to start over here on this the right side because it looks the craziest. What's another way you can write cosecant? 1 over sine, good. When in doubt, go back to the 1 over sine. Now, your book doesn't touch this side and it leaves it up here at the top. I'm not going to do that because 98% of success in mathematics is what? Yup, organization. Nailed it. So this is, I'm going to change this to sine. And then I'm going to distribute. And you see it just happening. The other big thing here is try to look at least one step ahead. Try to look ahead, okay? Because in your head right now, and it's just going to take practice, you guys. This is our first one. Sine times this, 1 over sine. This will give you cosine over sine. Bam, nailed it. Sine over sine, bam, nailed it. With this next step, we will have set ourselves up. Cotangent of x plus 1 is equal to cosine over sine plus 1. And I know cosine over sine is equal to cotangent. This is the end of your problem. You cannot stop it early. You cannot shortcut steps. All right? A little bit of shortcutting steps, but you need to write it out. This is a proof. A proof is you telling me how you got there. You already knew the answer. The answer was equivalent. The purpose of these is the process. All right? The purpose is the process. That's that problem-solving process. So on your test and as you work through these, that is the whole process. And everybody's can look different. And that's okay that everybody's looks different as long as you're mathematically correct. All right? It's okay for it to look different. These things take forever to grade because there's way more than one right answer. The goal with this is to be as efficient as possible, but you could chase